So, welcome back. After understanding table 1 and table 2 and also understanding using this table 1 and table 2, how do we identify a particular state to which zone it belongs to. Let us now come to table 3, which we have not yet understood or which we have not yet identified with. So, table 3 now actually deals with the single phase region. Yeah, table 1 and table 2 refer to normally two phase region or the LV saturation line, while table 3 would now take you to the single phase region. And what are these single phase regions? We are talking about subcooled and superheated zones will be the properties for these states would come from table 3. And also we can see subcooled to supercritical zone also can be seen from the table 3. So, subcooled, superheated zone and supercritical zone, the properties for any state that lies in any of these states can be obtained from table 3. Alright. So, let us again go back to our PT diagram and understand how the table 3, how different properties in table 3 are given. So, just to again sum up, this is our PT diagram, and as I have just said that anything that lies on this LV saturation line are going to be dealt by table 1 and table 2. So, saturation line, table 1 and table 2, one can get the properties of all the states that lie on this LV saturation line. But for other zones, for example, subcooled compressed liquid zone, superheated vapor zone and supercritical zone, I will get all the properties from table 3 now in this case. So, for all these things now, I will have to look for table 3 in the steam table. So, subcooled and superheated zone, let us see one example of this. So, this table 3 now, the information is given for lowest pressure of 0.01 MPa up to 100 MPa in table 3. So, we have got respective tables for each pressure 0.01 MPa, 0.02 MPa like that up to 100 MPa. You can see the range of the pressure is very high, it goes beyond the critical pressure. Critical pressure is 22 MPa, but we are talking about 100 MPa, as high pressure as 100 MPa. Most of our water related operations are up to or they are in subcritical region below 22 MPa. But here we have got properties up to very high pressure 100 MPa, that is almost 1000 bars, 1000 atmospheres. And for each of these pressures, we have got temperatures range of 0 degree centigrade to 1000 degree centigrade. So, you can understand how exhaustive data we have in these steam tables. For all these respective pressures and temperatures, we got all the property data of water. Again, some increments will be given with respect to pressures and with respect to temperatures, and for intermediate property values, we must interpolate between the two closest values. This is an approximation which is perfectly valid, and we have been using that both in table 1 and table 2. Can I just show you now table 3 just for an example, so that we can see how the values are given for different pressures and temperatures. So, this is table 3, water subcooled, steam superheated, that is the title of this table. Let us look at the first pressure, and as I said, P is equal to 0.01 MPa in this case. Alright, so you can see that it starts from pressure 0.01 and the temperature ranges from 0 degree centigrade in this fashion and goes up to 1000 degree centigrade. So, you can see all these values, all these properties are given for a given pressure of 0.01 MPa for various temperatures on one page. So, this is one page of table 3. And now, if I go to next pressures, you can see 0.02 MPa now, and correspondingly again see that it is up to 1000 degree centigrade. Alright, I will go through the details of the properties that are given in table 3, but here I just want to show you how the tables look. Then we got 0.03 MPa, and similarly I can go on higher and higher pressures, and here we can see it is now 0.07 MPa, this is 0.26 MPa now, 2.6 bar, alright. And in this way we can go down to very high pressures, 40 MPa in this case, again the temperature ranging from 0 degree centigrade to 1000 degree centigrade. What you can see here, the increment is of 20 degree centigrade in the later part, it is around 10 degree centigrade or 5 degree centigrade in the earlier part of temperatures. So we have to do correspondingly the interpolation together to get the respective properties at a given temperature. And you can see this is the last pressure, that is 100 MPa, again ranging from 0 degree centigrade up to 1000 degree centigrade. So got various pressure from 0.01 MPa up to 100 MPa. In the latter part of the pressures, the increment could be of 5 MPas or 10 MPas. Similarly, in the temperatures we have got 1, 5, 10 or 20 degree centigrade increments given for respective pressures. So coming back to slides now, if I want to see now these values for a given pressure, for example, some pressure is given over here, and if I go on increasing the temperature for a given pressure, you can see from this PT diagram, and if this pressure happens to be less than critical pressure or less than 22 MPa, and the initial condition happens to be in a subcooled region, alright. So you can locate that I will be in a subcooled region somewhere, and if I go on increasing the temperature now, understand what I am saying. I am saying that the pressure is less than critical pressure and temperature is less than Tsat value for that pressure. In such a condition, if my state lies over here in a subcooled region, and if I go on increasing the temperature now, I will come across a point which will hit this LV saturation line. It means that when I increase the temperature, the phase change would occur, alright. So in this direction of arrow, if I go on increasing the temperature starting from a subcooled region, this particular state, this particular system will undergo a phase change because it lied initially in a subcooled region. Similarly, if I start increasing the pressure from a system which lied in a superheated vapor zone initially, maybe in this zone somewhere at this point, and if I go on increasing the pressure now, I will again come across phase change. This is what one can actually see from the table 3 also, alright. So if I am from subcooled region, if I went on increasing the temperature, I will get a phase change, or if I am in a superheated vapor zone, if I go on increasing the pressure, I will come across a phase change, and this will happen when the temperature is less than critical temperature, alright. Superheated vapor zone, when the temperature of the state is less than critical temperature. What will happen if it is beyond the critical temperature and pressure? For example, here the initial pressure, although it lies in subcooled region, if the pressure is more than the critical pressure, that means if the pressure is more than 22 MPa, and if I went on increasing the temperature, I will not hit this LV line anymore because my pressure was more than critical pressure, and therefore if the system lied in a supercritical region, that means the pressure is more than 22 MPa, but I am still in subcooled region, and if I go on increasing the temperature, I will not come across a LV saturation line, the phase change I will not realize. Similarly, if my condition is from a temperature which is more than critical temperature, for example in this case, so initially the system lied in a superheated vapor zone, but beyond the temperature of T critical, that is 373.946 degree centigrade, and if I went on increasing the pressure, in this case also I will not encounter phase change because beyond the critical temperature value or beyond the critical pressure values, there is nothing called LV line, or there is no phase change line that exists over here, and therefore I will encounter phase change only in those cases when the pressure is below the critical pressure or when the temperature is less than the critical temperature. Alright. So, this is one should understand this, and we would see that again in our tables also. Thank you very much.